Hello everyone, welcome to my channel. Today I'm going to speak about semantic memory. Semantic memory. This is basically a storehouse of general knowledge which include our knowledge of words. As its name suggests, and it also includes our knowledge of concepts in different areas like geography, mathematics, and every other class of knowledge, verbal as well as non-verbal. For all kinds of factual information that can be brought to conscious awareness and expressed explicitly, semantic memory is the component of cognitive memory that contains information not bound to any particular event, and it is organized by conceptual properties rather than by the order of experienced events. Semantic memory is the memory necessary for the use of language. It is a mental thesis, organized knowledge a person possesses about words and other verbal symbols, their meanings and reference, about relation among them, and about rules, formulas, and algorithms for the manipulation of these symbols. Semantic memory does not register perceptual properties of inputs, but rather cognitive reference of input signals. The semantic system permits the retrieval of information that was not directly stored in it from the system, leaves to its components unchanged or uncharged, although any act of retrieval constitutes an input into episodic memory. Semantic memory as a hierarchy of concepts, one of the earliest, most influential modern models of semantic memory, suggested that knowledge is stored in a network of interrelated concepts, and that is, knowledge of network is organized as a hierarchy with its specific features at the bottom of the hierarchy and more abstract general feature at the top. The kind of hierarchical network for some components of semantic memories includes, for example, if we have informations like an object which has wings and it can fly, it has feathers, so we resemble of those optional informations into a picture that is bird resemblance of an object. So that kind of informations could be turned out to be semantic memory. This is an efficient way to store knowledge. The system does not have to explicit stories of information for each exemplar, that is, each particular item to be remembered. Instead, it can more effectively store common characteristics of several exemplars at higher levels of the hierarchy. This model was tested in famous experiments. It predicted that if semantic knowledge is organized as a hierarchical network, the amount of time required to answer questions should be related to the number of steps in the hierarchy that must be traversed to find the answer. This kind of model that could be instantiated by a simple mechanism connecting items according to the strength of the association between them. This notion presumes that features within a level occur together more frequently and therefore are more closely associated than features stored at different levels. Example, the feature yellow is closely associated with carinese. Yellow appears virtually every time we think of canary. If indeed association between concepts underlie the construction of hierarchical organizations, exceptions to the orderly hierarchy sequence should occur when strong associations between features bring large hierarchical distance. It has been found that some statements about some associations that bridge large distances in a conceptual category we verified more quickly than other statements that involve looser association among concepts stored close together in the hierarchy. Semantic memory refers to memory for knowledge and facts. Semantic memories could also be stored as different sets of distributed networks. A modern approach to understanding the organization of semantic memory involves distributed network models. In these different kinds of models, embodied as computer simulations, concepts are represented as different patterns of activation across a network of interconnected units. Each unit can be conceived as representing some feature of a concept. The units do not have to correspond to a nameable feature or concept. Instead, they may represent merely some aspect of a feature that cannot be named. Conversely, a nameable feature such as has wings might be represented across many units. In case of a distributed network model, knowledge is encoded in the different strengths of connection between units. Typically, the units are organized into modules that correspond to one type of information, such as visual or auditory, or serve a particular function like input or output. Units within a module are typically more richly interconnected than those between modules. Thus, a variety of network models can be created to simulate assorted systems and perform various functions. Namely, we have different kinds of models of semantic memory. Basically, the most important model of semantic memory, which include the three molecules corresponding to verbal inputs, visual inputs, and semantic representation. Each composed of separate modules for visual and functional units. In this model, both visual and verbal inputs are both connected to the semantic representations. They are not connected to each other. Most important characteristic of this model is then they exhibits graceful degradation of a gradual ratio, then catastrophic delay of function when presently the model is compromised. Thank you.